All right, so last time we covered the conservation equations, right? Mass, momentum, angular momentum, energy. And just briefly, I want to start today with the second law of thermodynamics. And I'm not going to go into a lot of detail because we won't use it a lot in this class, but it will come up just once or twice. And so, I want to refer to it by a special name, and I want you to know what I'm saying. So I'm going to leave sort of the concept of entropy to a thermodynamics class. I'm sure you've all had at least an undergraduate course in thermodynamics and you're familiar with the concept of entropy. So I'm just going to assume you know that, and we'll just kind of write down the second law of thermodynamics, but in a form that sort of follows what we've been doing in this class. So, in words, the second law says that the rate of entropy increase has to be greater than or equal to the entropy input rate. So, the total entropy in a system would be something like this. So where this little s is the specific entropy, and that's the entropy per unit volume. So this is the total entropy. And of course then, we're interested in the rate, so we want to take the time rate of change of that. And that's got to be greater than or equal to the entropy input rate. And so I'm just going to write down, so this is the, rate of mass generation, R, it's like a radioactive term, and energy generation. So, and T is the thermodynamic temperature, and that's equal to the minus of the heat flux over the temperature dotted with a normal over any bounded system S, so the boundary. So, this is basically, should be somewhat familiar from thermo, and again, I'm not going to get into all the details. But then if we just do, sort of use our tools, over on the left-hand side, we'll use the Reynolds transport theorem for this guy. Should be familiar by now. And then the second one, we'll use the divergence theorem to convert that to from a surface integral to a volume integral. Right? And so for this to hold over any arbitrary dV, then we have this. Okay, and this thing is called the Clausius Duhem inequality. Anybody seen that or heard that before? Clausius Duhem? Yeah, so Clausius is the guy who introduced the concept of entropy. Right? So I just wanted to quickly write that down so that later on when I refer to it, you have a reference. You can go back, okay? So